My name is Jean-Pierre Fleurial. I work at the NASA Jet Propulsion Laboratory. Thermoelectric generators have been used in space for a long time, actually since for over 50 years. And they have enabled a number of space science and exploration missions to the moon all the way out to interstellar space. You may know that the longest space power system is right now one that was launched in 1977, and it's out in interstellar space, so it's over 37 years now. Those thermocouples are actually, you may have heard of it, but they are actually what is, you have it in every day, so you have it in an oven. And what it does, it's a combination of two semiconductors that produces electrical power when you establish, when they operate across a temperature differential. You're adding heat on one side. The electrons get a little excited. It's great, I got some heat. They want to diffuse to the cold side, and nature doesn't like that. And so what it does is that there's a potential barrier that rises. It's called a Seebeck voltage. So that's a principal thermocouple, and in your furnace it just produces a few millivolt. It tells you the temperature. In space, for a power system, it produces up to hundreds of watts. So this technology has been extremely reliable, but it's not very efficient. And so in terms of how much electricity it produces for a certain amount of heat. So the result is trying to, my field of research is in trying to improve the conversion efficiency from heat to electricity of those materials. That's why I really love thermoelectrics and research field, material research, because there are problems there for everybody. The physics, the chemistry, the mechanical engineering, the thermal engineering, which include nanostructured materials, nanowires, composites. And because those materials need to operate at a very high temperature, it is often quite a challenging materials. Not only could be used in space, but people are looking at it potentially for other applications like waste heat recovery or portable power systems. It's actually the same technology is currently used in in a number of applications for cooling. A lot of cars, for example, use the same thermoelectrics for heating or cooling your car seats. We're looking at using the technology for more demanding space science missions that could go in extreme environment, or one that require extreme longevity, like people thinking about 100-year missions, and as well as for space exploration. So it's one of the technology that could be used for space exploration mission for using larger power systems on the surface of the moon or Mars. We will be talking about tens to hundreds of kilowatt, which everybody agrees would be needed if we are to establish kind of permanent outpost on the moon or on Mars. So that's what is exciting, that as a technologist, what we are trying to do is we want to see our technology make it and fly and go to outer space in the service of space science and exploration missions. So